So thank you all very much. I don't want to embarrass anyone, but could I have a show of hands of anyone who saw that for the first time today? Excellent. Very good. Welcome to all of you. I think there are a number of people here who could probably recite it, much like the Rocky Horror Picture Show. But it's nice to have some new listeners as well. So our next event, I'd like to introduce a panel of people who were there or participated or drove this event. You'll recognize some familiar faces to talk a little bit more about the demonstration and the work in Doug's lab that led up to it. So let me introduce these fellows briefly. On your right, starting at your right, is Andries van Dam. Andy was not a member of the lab, but he saw the demo, and I think the proper word would be smitten. And for those of you who know Andy, he can get very excited. And so he actually came down to Menlo Park and immediately started quizzing the team to figure out how they did it. And you'll hear from him about that. Next to him, I guess, is Jeff Rulifson. Jeff you saw on the film, looking very serious and slightly worried. He's actually rarely worried, but he was one of the principal software guys in this and managed to keep it all hanging together. Next to that is Bill Paxton, also a software person, but he claims that at the time of the demo, he was the new guy. He had started only less than a year before, had a degree in psychology, and sort of not a clue. Next to him is Bill English, the co-inventor, of course, of the mouse. And as Doug mentioned in the credits at the end of the movie, the sort of producer, not only of the demo, but of a lot of the hardware and project itself back in the lab. And finally, immediately to my left is Don Andrews, another software guy. He and Jeff were probably the double star that made most of this happen. So I'd like to start by saying that Doug looked like a pretty cool demoer. And I wonder if that was true of the whole group back in Menlo Park, or was there some excitement? Jeff?
Yeah, people have asked me this. On that day, just that day, we were in panic and focused. And so I guess you'd call it excitement, but it was tunnel vision. Computers were actually more unreliable than they are today.
Well, so did it crash?
Yes, it did crash during the demo. Very few people knew that. We built a special program in to try to restore it as quickly as it possibly could. And if you could look, there was a 16 millimeter film made from which this was made. And if you look at that film, there was one frame for 1/24th of a second where the crash message came up. And Doug didn't know it happened.
So Bill, one of the things that was most impressive to me, actually, was the video and communications technology. And at the time, the notion that a small group of people could go off and do a demo, even at 40 miles from the lab, seemed miraculous. And I gather you're the guy who made all that happen.
Well, I did organize all of that. It was not as difficult as it seems. We had Pac Bell, we had a Pacific Bell then, before AT&T, provided the video links, and they'd done that for remote television broadcasts. So they set up 2 video links for us. Actually, they had just shoots from SRI up to Skyline Boulevard and from there to San Francisco. But we had 2 links, and wherever I could, I provided some redundancy.
And if all that had failed, then what?
Well, Doug would have had quite a time in that auditorium by himself.
Right. Well, he wasn't tested, I guess. So you saw an excerpt, obviously, of the demo. What are the pieces that were missing? What are the sort of ideas that didn't make it into the demo? Or what are even the things that you had to leave sort of on the cutting room floor the week before for fear that nothing would work?
Who are you asking?
Anyone. Bill?
Well, I could take a try at that a little bit. Technically, I think almost everything is in the demo. But the deeper ideas that Doug had about bootstrapping, building tools to help you build tools, and his coevolution ideas about how you change tool systems and you change human systems and how those should evolve together, isn't really discussed in any of that. So it's a demo in a sense of the technical stuff, but not the deep stuff that was going on in the group.
I can tell you one thing about that didn't make it into the demo. As I said, I was the new guy and was pretty much clueless. So what I was most impressed by in the demo was Stuart Brand, Whole Earth Catalog, was our photographer. And he was down there, and talk about somebody to loosen up the atmosphere. Stu was behind the camera, and one of the first things he did was focus it on a monitor and zoom in so that the image filled up the entire screen, and he was getting this great feedback loop that was doing very much this psychedelic thing. So this is basically where things were behind stage.
A little.
Do that at home, that's really cool.
Nice. So it strikes me looking at this today that a thing that we all take for granted today, and even before Google took over the world, is search. And yet this system was more about structure and very little about search. Can you comment on that? I mean, was there search in the system? Was it simply not part of the way it came to be used?
I know for sure there was search within a file. And if you saw the system organized, all of your information was organized into these chunks, sort of sentence or paragraph-like things. And you could very easily set up a full regular expression. This was not for the naive users. So if you were a computer scientist, you could set up a regular expression search, and it would just extract all the nodes that match that. I don't know if we had cross-file searching then.
Remember, put yourself back. This was a group, an entire group, sharing a computer that I think is roughly as powerful as, it was like, if you measure the power of the thing in iPhones, it was a milli-iPhone. You know, it was 1,000th of an iPhone that this whole group was using. For 10 people or more. It was nuts. These guys did absolute miracles. You did a nice job on the hardware, but these guys did miracles to fit that thing in there. So search, being able to, there was nothing to search, number one.
Well, fair enough.
I mean,
The hard drive on the system had 96 megabytes.
And you shared that.
And we shared that among all the
Right.
users.
yeah, some of those numbers are just mind-boggling. How much memory was there? And it was,
There was, the address space was the killer. There was 64K bytes of address space,
Yeah,
but there were 192.
kilobytes of page.
So I don't know about in the audience,
this is getting, yeah.
but back where we were listening when we saw the overlay structure, there was a gasp.
Yeah.
Because then you knew that there was a limited address
Yes,
space.
overlay structure was a key term there, which would, for a lot of people, because now you don't need
You
it.
don't know, right?
But having 96 megabytes at your disposal was a big thing then.
Yeah, yeah.
And searching 96 megabytes is not that difficult compared to what we're doing today.
Yeah, I understand. Right, but the computer was rather slow.
Yes.
That's right.
So Andy, I got the impression that these guys made it all work, but they didn't quite know what they had, and you went down and figured this out?
Well, not exactly. It's too much to figure out. First, I just want to describe my reaction. I want to give you a TLA. OMG. This defines OMG. I was blown away, and in fact, I was the doubting Thomas. I couldn't quite bring myself to believe that it was all for real. So I went up to Doug afterwards, and I questioned him pretty hard. And being the gentleman that he was, he tolerated my skepticism and invited me to come and inspect the wares, and I spent 2 fantastic days at ARC being immersed in the technology, and later wrote up the algorithms and data structures that they used in a paper that compared a number of such systems. At the time, I'd been working with Ted Nelson on our first hypertext system, and I had a team of 3 part-time undergraduates. So to come and see this professional system with this unbelievable richness and complexity was an otherworldly experience. And this and the Sketchpad demo stand up today. You can learn from it today. They stand the test of time, unlike just about anything else that I've ever seen. The thing that I took away above all the stuff that you saw demonstrated today was the deep and systematic, principled design methodology that these folks used. It was unbelievable how deep and how broad it went. And I'd never seen software engineering like that. We were working in the hammer and chisel phase of the Industrial Revolution, coding and assembly language, and we were pretty good at it. But here, these guys had invented machine tools, a la Babbage, and had built tools to build tools, and this whole recursive bootstrap idea, starting with the system itself and working itself all the way up through augmenting human intellect, was just mind-boggling. And it informs us today still.
So let me expand on that a little bit. So, Jeff, you had the segment in the demo about the tools and bootstrapping and so on. And let's, first of all, I invite you all to comment a little bit more about exactly what some of those tools were and how they developed, and also the impact that they may have had later. But also, it seems to me that in a small group, or even especially a large group, but even a group your size, coordinating bootstrapping is actually quite tricky because everything comes to depend on everything else pretty quickly. Mm-hmm. And so there must have been some excitement around bootstrap events, I would gather.
Where do you want to start?
Put Don on spot.
Yes, we'd actually, there was an engineer named Val Shorey down at System Development Corporation that had come up with this idea of a little tiny compiler. And we used that to build a bigger compiler, out of which we built a bigger compiler. And we worked and worked and worked on it till the languages that we were writing in were actually compiling denser code than you would do if you did things by hand. It was...
First of all, C was not an option.
C was not an option. That's
Not
right.
even predecessors of C
Not
were
even
languages.
the predecessors.
Right. We had a language called Machine-Oriented Language 940, which was a fully structured language, but everything about it was tuned to that machine because every word mattered.
But it wasn't just compilers that you bootstrapped.
Right. Technically, there was also the entire command language was specified in this whole bootstrap building on top of building way so that we could change things instantly. I think Don did a lot of that.
We knew from the onset of, based on Doug's vision, what we were trying to do.
And how fast he changed his mind.
We were essentially bootstrapping ourselves, and things were going to change very quickly. So we were looking for ways of rapidly prototyping user interfaces and building a framework, an infrastructure that we could go in and build something over again on top of very quickly. And so the compiler writing trick was one of our tools in our kit bag. And we used it in thinking about Doug talked about the command language or the control language, which is basically a description of everything the user does to get the computer to do what you want it to do, plus the feedback that comes back. And
It was a state machine, really, wasn't
Yeah, it was.
pretty much.
Yeah.
We developed a language for describing that.
State machine, yeah.
We call that the control meta language. And we developed a compiler for processing those descriptions, which ended up being a chunk of data which went into the
Table,
system
yeah.
and was interpreted. So we had a command language interpreter inside the system, and all of that controlled the user interface. And if you didn't like it, you could sit down and write your own and try other, experiment with other kinds of interactions. But at the same time, it made the user interface across the entire system pretty consistent because everybody was using the same low-level things. When you wanted to collect a mouse click off the screen, there was only one place to get it, and
Bob,
so
I think,
forth.
I'm sorry. Go ahead. One of the interesting, this ties back to something you were saying earlier, one of the interesting examples of sort of how do you get from here to there was when you'd move to a new kind of computer architecture. Jeff was talking about how the language is really tuned to one machine. Well, then when you go to a new machine, that means rewriting everything.
So how many times did
Rewrite
you go to
in
new
new-
machines?
Too many. But one time in particular came not too long after this demo when there was this new idea about, some of you have heard of an internet, and before that was the ARPANET, and that started with 4 sites. One of them was at SRI, and one of the other ones on that little newborn little tiny net had the kind of machine we were going to. And so Don had the idea of bootstrapping ourselves using that resource over what became the internet. So I think we were probably about the first people to actually sit down and use in our jobs as opposed to being the developers of the internet, to actually use it to get something useful done. There are a lot of firsts in this crew. Dom was the first telecommuter from home.
We took the compiler and basically changed the output instructions to produce instructions for the new computer and left the rest of it the same. Produced the output. Oh, by the way, there are different word sizes and things like that. And shipped the object code to Utah to run on their machine and debugged it over the internet, over the ARPANET, which was an interesting experience because
There were 4 nodes on
various pieces of software were only staying up for so long at any one point in time.
What data rate?
I think most of they were 50 kb.
Yeah, 50.
If you cared about data rate, you would get a tape and get on a plane and go.
I actually did that.
That was the fastest way to get
The
bits from
program
A
was
to B.
small, presumably.
Yes, they were not outlandishly large, but
Right. So let's oh, sorry, go ahead.
Before you leave bootstrapping,
Yeah.
the other aspect of it was we used that system for all of our own documentation very effectively. We wrote reports on it, and you could write a report and make major revisions and have it done the next day. And that was an important part of the bootstrapping.
and it linked right into the software.
Right.
Which is on the system.
I think the real bootstrapping issue is exactly what you hit on, is that you're using the thing you're building.
Every day.
Yes.
Every day.
Right.
And
Well, that's one of
your
the dependency
friends
issues I was
down the
referring
hall
to.
are using
Yes.
what you're doing.
They were
It
the
matters.
inventors of dog fooding, basically.
Well, and you know whom to go talk to if you have a problem.
You do.
Yeah.
No, but that's where the bootstrap spiral really takes off.
So let's talk a little bit about sort of day-to-day in the
Let
lab.
me just amplify
Yeah.
your statement, because each statement had the identifier of the person who last edited it. So you literally knew who to
You
go talk
literally
to
knew who's
when the
winning.
program didn't go.
What were you thinking about?
Yes. Yeah, just like dogs again. So I get the impression that the demo was really sort of the first public unveiling of what you guys have been working on. So that I'm guessing that there weren't a lot of visitors to the lab that got demos before this, with a possible exception of funding
There were quite a
agents.
few visitors.
Well, and were you the guy who got to deal with them?
No, everyone.
I see.
Everyone.
So did the demo, was there pre-demo and post-demo as far as the lab went? Did things change? Did the kind of people coming by or the kind of work that went on change in any way?
I think the demo was a big punctuation mark in an ongoing stream of work. And we always had more things we wanted to implement.
Well, it brought people in, for sure.
Yeah.
Yeah, and we had a large 16 millimeter projector that you could stop frame. So you could show film in it and stop it and click it one frame at a time without burning the film. It had some special thing in it. And I remember having to lug that thing a number of places around the country for Doug.
And that was basically re-showing
This
Right.
film to
Right.
people that were all of a sudden interested.
Right.
And having to go through all kinds of things with the airlines because I wouldn't check it and I had to carry it on and da-da-da. Why was I doing that?
The freeze framing.
Oh,
Oh,
freeze
you
framing.
freeze frame to show
Yeah,
because nobody
yeah.
had a clue what this thing was flying around on the screen.
Right, and if you step through the film very carefully, it's really quite amazing to see how powerful the system was. There's a sequence in there that I used to show to people where the cursor is down in the corner of the screen, and then Doug is deleting a character and a word in the middle of the screen. The cursor's down in the corner, 24th of a second later, the character is underlined, showing it's been selected, and the cursor is slightly above it. And the next 24th of a second, the cursor's in the upper right-hand corner of the screen, and the character is gone. So to show how powerful and fast it was, you needed to go one frame at a time and step people through it.
Yeah, it's interesting. It really is a visual kind of thing that you just can't, it's hard to get back there because you grow up with it, people now. But when I first came in as a job applicant, you did a demo of this thing. And I vividly remember you going through doing the first editing task on this little display, and me going, wait, what did you do? Do that again. What happened? Because it was so foreign.
Yeah.
Yes, you
So-
had never seen anything like this.
So Andy, maybe you'd care to comment. You were working in this general area at the time, and certainly since. And say a little bit about, you mentioned the OMG moment, but how did this relate in a more technical or, in a larger context of other things going on? What was the big learning you took away back to your own work, for example?
Well, I think the big thing that I saw was just this vastly expanded vision of what you could do and what you should do. So the first thing I did, we were already working on the second system at that point, is trash the specs and say, let's steal the best ideas, which we did. So we adopted outline editing and view specs and the command language interpreter and a whole bunch of other technology. So I think it just opened up the vision of what could be done. What we never did manage to duplicate was that incredible depth of software engineering with the bootstrapping of the tools themselves. We did work for 4 years on what we called language for systems development. Remember when this was? And it was a splendid optimizing compiler, but it was never robust enough to put into practice. In any case, I would say breadth of vision is the most important thing I took away.
So, yes, thank you for mentioning that. You brought up the word stealing, and I want to cast your minds back.
On the shoulders
well,
of giants,
absolutely.
just like
So
you're
this
supposed
whole
to.
project was done before the word open source was coined, but the project, as nearly as I can tell, was pretty much open season on almost everything. Jeff, I know you have a list of things that you went around and copied or stole in order to...
If you looked inside the system, the way the nodes were stored and manipulated and that whole structure was taken directly out of Lisp. The way that any editing was done and all of the searching and all of the filtering was actually taken from Snowball, which was a regular expression string language from Bell Labs. The meta compilers we got were, the first idea for that came out of System Development Corporation, and they were extremely supportive, and I made a number of trips down there helping us get that going, because we took their ideas and pushed them way farther than they ever thought we'd push them.
Do any of the things come to mind to others of you? What about the hardware, Bill?
What was your question?
Well, so what did you copy from others, or went around finding best stuff that you could steal and just use?
I don't remember anything in particular. I mean,
But the hardware was all stock hardware, correct?
It was pretty much all stock hardware. Well, there was hardware built with the machine. There was a memory interface channel and a bunch of interfaces we built to the computer, which were very, very unique. But I don't think they were copied from anybody.
What about this pointer thing? What about this pointer thing?
Oh, the pointer thing.
That thing that you pushed around on the table?
Oh, you mean we finally called it a mouse?
When did that happen?
When did that happen? Well, that happened really in '63. We had a contract with NASA to evaluate different display pointing devices. They use displays a lot for very different things, but we had a contract with them to evaluate pointing devices, and I got that contract to manage, so I collected different devices, and Doug had a sketch of this mouse in one of his notebooks, the idea of you could turn wheels upside down and run them. So I took that and thought that looked pretty good and had SRI Machine Shop build that for me. And one of the guys who worked for us said he would carve a box for it. So we included that in our evaluation experiments. And it was all described in the report, and it was clearly the best pointing device.
So what got its name? Who coined it, or is it obvious?
You got a box on the table, and if you're referring to it, you don't want to say that the joystick, the light pen, the box on the table didn't quite work.
Okay. So I went back and read Doug's 1962 paper about augmenting human intellect and some of the dreams in there, and there's kind of two parts. There's an early part which is quite abstract and I think actually even difficult today to try to figure out what Doug was driving at. The second part gets much more concrete and gives some examples, none of which have anything to look at all like what NLS turned out to be. And it begs all kinds of questions about what it was like to get from the abstract to the concrete, what it was like to have, Doug, the abstract idea guy, working in the midst of guys who were actually trying to get something working. Can you say a little bit about that? I mean, was it a straightforward process? Well, this is, by the way, I don't mean to pick on Doug. I think this is characteristic of visionaries. It's characteristic of visionaries that they have an awful lot of difficulty converting things into something that the rest of us can consume. And it's one of the reasons, I think, why the word amanuensis is in our vocabulary. Now, in these amanuensis, what's the plural? It's not just literally writing down what the master says, it's having to interpret the master's vision and turn it into something that actually doesn't break the laws of physics. And so there must have been a lot of that, and it must have been a less than smooth process, I'm guessing.
Yeah, I remember many tense sessions with Doug between what he wanted and what we could actually do. Because we had, the SDS 940 was full, so to speak. I remember when we were down to like 4 memory words in a page, and Doug wanted a whole set of commands implemented, right? And so something's got to go, or, so there was a lot of discussion about all of that. And a lot of translating it down to something that we could actually do in the machine.
Would it be fair to say that the system evolved in a kind of steady way, or were there major places where you threw out stuff as a bad idea and restarted? Were there sort of major phases in the evolution of the ideas?
So before we had the SDS 940 that was used for the demo, we had a CDC, I think it was a 3300 or 3100, 3100.
We had a 31 to ourselves, yeah.
Yeah, and we had built some major pieces of the system on that. We didn't.
We should give the background to the 31. That was a single user machine.
Right.
Single user, yes.
And this was moving to the 940 was a major breakthrough. We were using brand new technology to try to let several users share the machine simultaneously. So there was a lot of things were happening at the same time in all of this.
But we did actually bootstrap off the 3100. So and when we did that, we went into the time-sharing mode, and we also went into a very much expanded command language and feature mode. Then there was freezing the code before the demo. That was an interesting experience. Doug wanted stuff. He and I wanted the demo to work above all else, and we froze it. And there was some frustration over all of that. But at least we knew what bugs we had.
Right.
I'm sure Doug was horribly frustrated trying to communicate these ideas. And I know on me at least, a lot of it was lost. Trying to get it down to the level of making code that would work was, and today's bug was my focus, and his was generations after.
And partly because the machine was so small that we couldn't put a lot in it, so the mechanisms that we put in it had to be extremely general, an extremely general purpose. And so it had this very nerdy computer science regular expression flavor to it. That was so it could be extremely general and
tiny.
And tiny. And that a lot of the why don't you do this, why don't you do that was because it either fit in the structure or we couldn't do it.
So I presume that sometime in the project after the demo, this constraint, this machine size constraint was relieved in some way by going to better machines?
Yeah, it went from 1 milli iPhone to 5 milli iPhones.
Okay. But so then the system got bigger or faster or
Well, Bill
different?
was around for more of that. That was when you went to the PDP-10.
That's when we went to the PDP-10. Yeah, I basically could do more things, support more people. It gradually got more reliable. And I think a few more of Doug's ideas got into it, but that was.
So we saw in the demo, speaking of ideas, we saw use of video inset from people and collaborative audio and so on and so forth. Was that actually routinely used in your lab, or was that a system feature that was more appropriate when you were 40 miles away?
That was pretty much put together for the demo.
That was
I had a computer.
Doug's vision coming up as opposed to what we.
Okay.
I had a video mixer at the back of the auditorium along with the projector. And the thing that was done in software was the ability to put everything on one side to make room for the pictures. But using the pictures was for the demo.
In the workspace, we were in a wing of the SRI building, and we took out all the stuff in the middle of the wing, so we had a big common area. And then we'd set up machines with tables in the common area, so we could just sit and work and see each other.
So the collaboration was done the old-fashioned way mostly.
Yeah.
Which was particularly exciting when the machine would crash, because you get this collective sigh. Yeah,
It was more than a sigh.
Runs to push
yeah,
the
but
boot
sigh is not quite the right four-letter word.
button.